When global temperatures change, the explanation we hear most often is simple. More CO2 equals more warming. But Earth's climate system has never been driven by a single variable. Long before industrial emissions, temperatures rose and fell, sometimes sharply, without human influence. So what was driving those changes? In today's episode of Sustainability Ventures, we explore why solar activity cycles provide a powerful and often overlooked explanation for many observed temperature variations. This is not about denying climate change. It's about understanding all the forces that shape Earth's climate, starting with the one that supplies nearly all its energy, the sun. Over 99.9% of Earth's energy comes from the sun. Every climate process, winds, oceans, clouds, ice, ultimately responds to solar input. Even small variations in solar energy can produce outsized effects because climate systems amplify change through feedbacks. The key point is this: climate sensitivity does not begin with greenhouse gases. It begins with incoming solar energy. To understand temperature variability, we must first understand how the sun itself changes. The sun is not constant. It operates on multiple cycles, the most well-known being the 11-year sunspot cycle, where solar activity rises and falls predictably. But there are longer cycles as well: the 22-year magnetic cycle, multi-decadal cycles, centennial-scale variations like the Maunder minimum. Solar activity influences total solar irradiance, TSI, ultraviolet radiation, solar magnetic shielding from cosmic rays. These variations may seem small, fractions of a percent, but history shows they matter. Consider the Little Ice Age, from roughly 1300 to 1850. During this period, winters were harsher, glaciers advanced, crop failures increased. This cooling coincided with prolonged solar minima, periods of extremely low sunspot activity. Earlier, during the medieval warm period, solar activity was higher and global temperatures were warmer without industrial emissions. These correlations appear repeatedly in paleoclimate records derived from ice cores, tree rings, sediment layers. The sun's fingerprints are written clearly into Earth's climate history. One of the most fascinating mechanisms linking solar activity to climate involves cosmic rays. When solar magnetic activity is strong, fewer cosmic rays reach Earth. Cloud formation may decrease. More sunlight reaches the surface. When solar activity weakens, more cosmic rays penetrate the atmosphere. Cloud cover may increase. Global temperatures may cool. This cloud modulation effect offers a compelling pathway by which small solar changes produce significant climate responses. It's not just how bright the sun is, it's how it shapes Earth's atmospheric behavior. Observed temperature records show periods of rapid warming, periods of slowdown or plateau, regional differences that defy uniform explanations. CO2 levels, however, rise steadily. If CO2 were the sole driver, temperatures would increase smoothly and consistently. Instead, temperature variability aligns more closely with solar cycles, ocean oscillations, volcanic activity, and atmospheric feedbacks. This doesn't negate greenhouse effects. It shows they are part of a larger system, not the system itself. Earth's climate does not respond to slogans, it responds to energy. Solar activity cycles help explain why temperatures vary, sometimes rapidly, sometimes unpredictably. Understanding climate means following the data wherever it leads, even when it complicates simple stories. This is Sustainability Ventures, where climate science is explored through evidence, balance, and honest inquiry. If this analysis added clarity, like, comment, and subscribe for weekly data-driven climate insights. Join the discussion below. Should solar variability play a larger role in climate assessments and policy models?